Hello dear students, today I will discuss how you measure the enthalpy change delta H per mole. From this video you can learn how you can measure enthalpy change per mole. This calculation is very important for Cambridge A-level chemistry practical paper and also theory paper. Let's move. Measuring enthalpy change delta H. So at first you have to learn energy transferred or energy change E equal mc del T. This is important formula. E equal E, or you can write Q, small q or capital Q. This means energy transferred E or Q equal mc del T. Here m is the mass of solution in gram. So what is m? M is the mass of solution, unit will be gram. C is specific heat capacity. This value is constant 4.18. Del T, change in temperature. So E equal mc del T, m equal mass of solution, C specific heat capacity, and del T how much temperature rise or how much temperature fall, change in temperature. And enthalpy change delta H per mole, enthalpy per mole enthalpy change per mole will be energy transferred E or Q divided by number of mole. I mean energy transferred, if you divide by number of mole, you will get enthalpy change per mole. So now you see problem 1. A student placed 25 centimeter cube volume is given, 1 mole per dm cube hydrochloric acid. So hydrochloric acid concentration is given, volume is given. In a coffee cup calorimeter and measured its temperature at 22.5 degrees centigrade. Then 25 centimeter cube of 1 mole per dm cube sodium hydroxide also at same temperature was added quickly to the acid. Sodium hydroxide is added into the acid. The mixture was stirred and the final temperature was recorded as 29.2 degrees centigrade. Temperature increases. So this reaction will be exothermic reaction. Calculate the enthalpy change for this reaction per mole of hydrochloric acid. And number 2, give two assumptions. First you think volume 25 centimeter cube hydrochloric acid and 25 centimeter cube sodium hydroxide. Total volume will be 50 centimeter cube. 25 plus 25 total volume 50 centimeter cube. So first E or Q, energy transferred E or Q equal mc del T. M mass of solution is 25 centimeter cube plus 25 centimeter cube, total 50 centimeter cube. 1 centimeter cube equal 1 gram, so 50 centimeter cube equal, you can write 50 gram. Mass of solution M will be 50 gram. C, specific heat capacity 4.18 is given. Del T, change in temperature, so highest temperature 29.2 minus 22.5. If you calculate, you get 1407 joule. If you take gram, then answer will be joule. Then after dividing 1000, you will get 1.407 kilojoule. You know 1000 joule equal 1 kilojoule. That means if you divide by 1000, you get 1.407 kilojoule. Then moles of hydrochloric acid, you know liquid formula, chemical calculation, N equals CV. N means number of mole, C means concentration, V means volume. So moles of hydrochloric acid, concentration times volume. Concentration is given 1, volume is given 25 centimeter cube, 25 divided by 1000. Centimeter cube is converted to dm cube. You know 1 dm cube equal 1000 centimeter cube. So if you calculate, you get 0.025 mole. Also you can calculate moles of sodium hydroxide, concentration times volume, you get 0.025 mole. So moles of hydrochloric acid and moles of sodium hydroxide same. Now you calculate enthalpy change per mole delta H equal minus. Why minus sign? Because temperature, you see temperature increases, so this is an exothermic reaction. Temperature increased, so this is exothermic reaction, and you know for exothermic reaction delta H value is negative, and for endothermic reaction delta H value will be positive. So this delta H value will be negative as temperature increases. So enthalpy change per mole will be energy transferred 1.407 divided by number of mole. Number of mole 0.025. So if you calculate, you get negative 56.28 kilojoule per mole. This is the answer, enthalpy change per mole. So you are asking write two assumptions, what you assume, and as total solution equal 50 centimeter cube, but you use 50 gram. Which assumption you take? You take 1 centimeter cube equal 1 gram. So 50 centimeter cube equal, you calculate 50 gram. And number B, no heat was lost. When you measuring the temperature, you know heat is lost, but you don't calculate losing heat, so that you have to assume that no heat was lost, because if you don't assume this, you have to calculate how much energy is, how much heat is lost. So when you calculate this, you assume that no heat was lost, and 1 centimeter cube equal 1 gram. Then next you see number 2. Problem 2. Zinc will displace copper from copper to sulfate solution according to the following equations. Copper to sulfate reacts with zinc to produce zinc sulfate plus copper. This is displacement reaction. If an excess zinc powder is added to 50 centimeter cube of 1 mole per dm cube copper to sulfate, the temperature increase 6.3 degrees centigrade. This also exothermic reaction because temperature is increased. You are asking, calculate the enthalpy change for this reaction. So as before, E or Q means energy transferred, mc del T. M is the mass of solution 50 centimeter cube, so 50 gram. C 4.18 is specific heat capacity. Del T 6.3 degrees centigrade. So if you calculate, you get 1316.7 joule. After dividing 1000, you will get 1.3167 kilojoule. Now moles of copper sulfate, concentration is given 1, volume 50 by 1000, 50 centimeter cube is converted to dm cube, n equals CV, number of mole equal concentration times volume, 1 concentration 1 mole per dm cube, 50 divided by 1000 centimeter cube is converted to dm cube, you will get 0.05 mole. Now enthalpy change delta H, this will be per mole. Enthalpy change per mole, delta H will be energy transferred, you calculate already, 1.3167 divided by number of mole. This answer will be negative because temperature is increased, so this reaction is exothermic reaction. You will get negative 26.3 kilojoule per mole. This also exothermic reaction. Next, number 3. Number 3, when 5.73 gram of sodium chloride dissolved in 100 centimeter cube of water, the temperature of water fell from 22.4 to 19.8. This temperature fall, so this is endothermic reaction. Calculate the enthalpy change of this reaction. That means calculate the enthalpy change per mole for this reaction. And what is given? Sodium chloride mass is given, and volume 100 centimeter cube. So volume M is 100 centimeter cubes, M will be 100 gram, and C 4.18. So now you see the answer. Energy transferred E or Q equal mc del T. M means, you think always mass of solution, that means liquid, not solid. So if you add 100 plus 5.73 gram, answer will be wrong. And m is the mass of solution, that means how much volume solution are present. So here you see 100 centimeter cube, that means 1 centimeter cube equal 1 gram. This is assumption. So 100 centimeter cube equal 100 gram. 100 gram. And C value constant 4.18, and change in temperature 22.4 minus 19.8, you get 2.6. If you calculate, you will get 1086.8 joule. So now 1.086 kilojoule. Then as this is mass is given, so to find out mole you have to apply solid formula. And how you calculate number of mole, you see, you will get moles of sodium hydroxide, I means number of moles of sodium hydroxide, mass is given divided by molar mass. Sodium 23, chlorine 35.5. So moles of sodium chloride equal mass given divided by molar mass of sodium chloride. So you will get 0.0979 mole. Then enthalpy change delta H will be energy transferred divided by number of mole. This is plus sign, why plus sign? As temperature fall, so this is an endothermic reaction. Answer will be plus 11.1 kilojoule per mole. So if temperature fall, delta H will be positive because endothermic reaction. If temperature rise or temperature increases, in that case delta H value will be negative. Okay, thank you dear students.